Okay, so here in section 8.6, we're doing the same thing with finding the area between two curves. The only difference on this one is that we have more than two intersections, whereas before the prior lessons, whether it was respect to x or y, we just had two intersection points. So now we're looking at, hey, there's more than two. And so that's going to, each thing's going to be a little bit different. You need to make sure you can spend some time of solving for all these x values or y values, depending on which respect we're doing it towards, by hand. Most likely the calculator ones are going to be when they give us things with the like sine and with e to some power, or ln and those kind of functions. So we're going to solve a lot of this by hand, just to make sure that we're good with those skills, because we hate to, in the spur of the moment on the AP exam, not be able to do factor something, just because we got lazy, used the calculator too much. So here they asked us to figure out what the A, B, and C points of intersections, label them from smallest to largest. And so with that being said, is A is the smallest, B is the middle, C is the largest. And again, we're going just off of the x values is all we're doing on this one here. So we want to take our two functions, go ahead and set them equal to each other. We're trying to find out when these two things intersect. So we're just doing our systems of equation here. Let's go ahead and bring over the x squared and the 2x and combine like terms over here. Again, the nice thing here is we get some stuff to cancel. 3x cubed, the x squareds cancel, then I get a minus 12x, and that's equal to 0. We can factor out a 3x, so that would be 3x times x squared minus 4. And now that's equal to 0. And then we want to go ahead and set each part. So we say 3x equals 0. X squared minus 4 is equal to 0. So x equals 0 is one of our points of intersection. And then x is equal to plus or minus 2 after we bring over the 4 and take the square root of both sides. So I have 3 of them total. I see 3 of them. So the smallest would be negative 2, then 0, and then positive 2. And again, that's just trying to get us to solve for each of those. They asked us now to set up the integrals. And we notice here we change which function is on top. The function that starts off on top ends up being on the bottom down below. So we have to set up two integrals. So we're going to go from more or less an integral from a to b, and then we're going to add the integral from b to c. So, and we can use the values in here that they tell us. Those are easy to write in there. So with that in mind, we're going to say the integral from negative 2 to 0 of, again, the equation on top is the cubic function. So that would be 3x cubed minus x squared minus 10x. Then subtract the quadratic function, so negative x squared plus 2x. All right, and that's dx. So there's the first part. Now I have to add the second part where I go from 0 to positive 2. And they trade roles, who's on top and who's on the bottom. So we start off with the quadratic part, and then subtract the cubic part. And we'll just clean this up. Again, always, I would not leave it like this on an AP test. I would do some combining like terms, is what I do if they just asked us to set up the integrals. I would do some. I would go one more step here. So the integral from negative 2 to 0, 3x cubed, and then that'd be a minus, that'd be a plus, and those cancel, so no x squareds, and then we'd have a negative 10, so that'd be negative 12x. Dx, and then we'd have plus the integral from 0 to 2, and then now we would have a negative 3x cubed. The x squareds cancel again, and then I make a plus 12x dx. And then we're okay with leaving it at that spot. That's where I would leave it at. Now, you can also, if you want to find the area of those two regions combined, We can also do it with the absolute values, but remember in an earlier lesson, we had to be careful where the absolute value bars were because they mean two totally different things. So if you want to do it, we could technically go from A to C, and we would have to do the absolute value bars now. Absolute value of the f of x equation minus the g of x equation. So for in our case, in this manner, it would be the cubic minus the quadratic is what we would set up here. And so we could set this up as from -2 to 2, absolute value of the x cubed minus x squared minus 10x minus, and then a negative x squared plus 2x. And then I want to do all of that. We can actually put the absolute value bar after, as I try to erase that last one, we could put the dx after the absolute value bar is where we would stick it. So there's another way you can do it. But again, got to make sure that the absolute value bars are inside there. And so therefore it might be safer if you can't remember where to put the absolute value bars, just set up the two integrals. Not too hard. Problem number 2, last one in the lesson. Again, it's just the only difference is we got multiple places. So we see that we start at -2, then we intersect here, intersect at this spot, and then we finish up at 2. So now I need to figure out, okay, what are my A and my B's of where these two things are crossing. So I got to go ahead and set 2 minus 1/2 x squared, set it equal to the line y is equal to 1. So we're trying to figure out when does that quadratic function, there we go, when does it intersect the horizontal line there? So when does it cross 1? So we'll bring the 2 across by subtraction, and that would give me -1/2 x squared equal to -1. I'd multiply both sides by -2, gives me x squared equals +2, and therefore x is equal to plus or minus √2. So the A obviously has to be the -√2, and the B has to be the positive √2. Now we're ready to set up our integrals. So the integral from -2 to -√2 of, now what is on top? Well, technically y is 1 on top. So I have 1, and then minus the quadratic function. And again, this is why I was trying to have you in our lesson on the previous one to include the number, like the x-axis, so that when we came to this one, we'd be okay here. So there's the first integral. Now I go plus the integral from -√2 to positive √2. The quadratic function is on top, so 2 minus 1/2 x squared minus the horizontal line, which is 1, and then dx. And then now I'm ready for the last part. Plus, back to using √2 to 2, and using the ones on top. So 1 minus, and then it would be the quadratic function. So 2 minus 1/2 x squared, and then all that dx. So make sure you have all your parentheses in here. So before you finish writing, make sure if you start with a parenthesis around each of those little parentheses, make sure you finish. Because if you accidentally leave that off and you write down like 2 minus 1/2 x squared minus 1, and then you go dx like that, they're going to mark that wrong. And because I'm going to mark it wrong too as well. Because that's only saying you're doing in a way, doing the 1 with respect to x. We want to say we're doing the whole inside part with respect to x as we take the antiderivative. So be very careful, making sure that as you start parentheses, you close them.